Final exam review number 2. It's talking about arc length and area of a sector of a circle. It's going to be talking about trigonometry and some function transformations. So it's kind of a mixed bag of stuff. Let's get going. Some formulas you'll need: area of a circle, pi r squared. Area of a sector of a circle, which is, we learned it as angle over 360 times pi r squared. Circumference of a circle is 2 pi r, or pi times the diameter. And the length of an arc is either degree over 360 times pi r squared, 2 pi r, or S equals r theta, where theta is measured in radians. So those are the formulas that we'll be utilizing for this section. Given the circumference of a circle, what is the arc length? So we know the circumference is 40. The arc length we're trying to find, so find the arc length. We know that the degree is 95 and the circumference is 40 pi. So we can use the circumference formula and the degree over 360 to find it. So we'd say L equals degree over 360, so 95 over 360 times 2 pi r. But since 2 pi r is what the circumference equals, we would just say 95 over 360 multiplied by 40 pi. Put that in the calculator, and then we can round to the nearest hundredth. And as you can see, that gives you approximately 33.16. Question 2. If x plus 4 squared plus y minus 6 squared equals 36 is the equation of a circle, what is the length of a 100-degree arc? Well, we got a lot of information here, but the formula for length of an arc in degrees is degree over 360 times 2 pi r. When given the degree, we can plug in that, but we don't know the radius. But that number in a circle equation is your radius squared. So if I know that the radius squared is 36, then the radius is going to be the square root of 36. Square root of 36 is 6. We can verify that in a calculator, SQRT 36. So we're going to plug that in along with the 100. So the length is going to be 100 over 360 multiplied by 2 pi times 6. As a decimal, that gets us 10.47. Well, one of these is going to give you that. So if you go through the answer choices, you can check 5 pi, you can do 10 pi, we can do 10 pi over 3, and you can do 20 pi. And as you can see, the one that matches up is 10 pi over 3. That's the same thing. So that equals 10 pi over 3. And as a decimal, that's approximately 10.47, which also is 10 pi over 3. Question 3, we have another circle equation. What is the area of an 80-degree sector? So we're going to use the area of a sector formula, degree over 360 times pi r squared. Now we have the degree, it's 80. This is r squared, so r squared is 121. That means r is the square root of 121. That's 11. And we're going to plug in 11 and 80. So the area is 80 degrees over 360 multiplied by pi times 11 squared. And again, we can get that decimal approximation. Let me clear these out. So 80 over 360 multiplied by pi 11 squared. And so that's going to give you about 84.47. And again, we can go back and see which one of these is going to give us the same thing. So we'll go to our answer choices. We'll plug in each answer choice. So 44 divided by 9 multiplied by pi, too small. 29282 divided by 9 multiplied by pi, way too big. 484 divided by 9 multiplied by pi, too big. So it's going to be D, 242 divided by 9 multiplied by pi. And if we approximate those decimals, we can visualize it here. So 15.35 or 36, 1022.1.3, 168.94, 95, 884.47. That's the same thing. So that's going to be your answer. Question number 4. The length of a 100-degree arc is 5 pi. What's the approximate area of a sector of a circle bounded by the arc? So we have the length, that's L, the degree. We want to know what is the area of a sector bounded by the length. So we're going to first start with the length formula. Length is degree over 360 times 2 pi r. We know the length is 5 pi. We know the degree is 100. So we have to figure out what the radius is. So what I would do in this problem first, since there's a pi, is cancel those pi's out. So it's going to be 5 equals 100 divided by 360 times 2 times r. So 5 equals 100 divided by 360 times 2. Our next step is to figure out what 100 divided by 360 times 2 is. So that's 0.5555 repeating. Times r. So we're going to do 5 divided by that number. And I go out several spots. So you can see it is going to be 9. All right, so that'll round to 9. So 5 divided by all the 0.5s repeating is going to be 9. So now I know my radius. Now the question wants to know what's the approximate area of a sector. So now I'm going to go to the area formula. Area equals degree over 360 times pi r squared. Well, my degree hasn't changed. That's 100. So area equals 100 over 360 multiplied by pi times 9 squared. Now we can plug that into the calculator again. That gives us an area of 70.685. And that's going to round to 70.7. Number 5. In the figure below, the larger circle has a radius of 6. The smaller circle has a radius of 2, and the angle formed at the shaded region is 30 degrees. What's the approximate shaded area? We're going to do the area formula twice. So we're going to do the area of the large minus the area of the small. Because if you look at the shaded region, it's that outside part. So the area of the large is going to be 30 over 360 multiplied by pi times 6 squared. And the area of the small is going to be 30 over 360 multiplied by pi times 2 squared. So we're going to get both of those different areas and then subtract to get the overall shaded region. So you can see the different areas are going to be 9.42 and 1.047. So if I subtract those two numbers, you're going to get 8.3775. Okay, questions 6, 7, and 8. They're actually going to use the S equals R theta. So the question says, what's the approximate length of an arc subtended by an angle of 4 pi over 3 radians? So that's your theta on a circle with a radius of 6 meters. So with that arc length formula, all we got to do is take the radian measure and multiply it by the radius. So 4 pi over 3 multiplied by 6 is going to be your length. So we can do that right in the calculator. That gives us 25.13. So that's going to be your arc length. 7, the diameter of a circle is 8 centimeters. A central angle of the circle intercepts an arc of 12 centimeters. What's the radian measure? So same formula. This time, we're given the diameter. Remember, the diameter is twice the radius. So if your diameter is 8, your radius is going to be 4. The arc is 12 centimeters, so that's your length, so that's your S. So we have 12 equals 4 times theta. So your radian measure is going to be 12 divided by 4. And that's going to be 3. So that radian measure is 3. And then lastly on this page, or on this problem, what is the approximate radius of a circle that has an arc length of 9.5 and a radian measure of 2 pi? So your arc length is S, your radian measure is 2 pi. So again, we're going to plug 9.5 in for S equals R times 2 pi. And we're going to have to divide 9.5 by 2 pi. And that's going to be your radius. And that gives you a radius of about 1.5. Part 2, trigonometry. We need to know a few things about radians and degrees, how to convert. If you have a radian measure, you multiply by the degree over 180, or you take the degree, divide by 180, and multiply by pi to get the radians. So it's basically degree times 180, or times pi over 180 to convert from radians. And then your radian times degree, or sorry, 180 over pi. A couple coordinates to be familiar with. 0 degrees, 30 degrees, 45, 60, and 90 on the unit circle. The radian measures can be found by dividing by, or multiplying by, multiplying by pi over 180. Know these coordinates. And let's get into some of these problems. Express 7 pi over 6 in degrees. So what we do is we take our 7 pi over 6 and we multiply it by 180 over pi. If you look back up here, we say 180 over pi. So that's going to give us 210 degrees. Number 2, William put the tip of his pencil on the outer edge of a graph on the unit circle at the point 0, -1. He moved his pencil tip through an angle of 4 pi over 3 radians. 0, -1 is down here. 0, -1, that's 270 degrees. He moved the pencil tip at an angle of 4 pi over 3 radians in the counterclockwise. With counterclockwise, you want to add. So what we'll do is we'll take 4 pi over 3, and we'll multiply that by 180 over pi, and you can see that's 240 degrees. So we're going to take 270, and we're going to add 240 to that, because we're going counterclockwise. Counterclockwise, the degrees count up. So we'll say 270 plus 240 . And that's 510. It says, at what angle on the unit circle did William's pencil tip stop? Well, 510 is not on the unit circle, so we want to subtract 360 from that. So we'll say 510 minus 360. And that's going to give you 150 degrees. So one of these radians is 150 degrees. So we're going to multiply by pi over 180. So to convert a degree to a radian, we take that degree, multiply it by pi over 180. That's your radian as a decimal. So if you don't want the decimal, you do 150 divided by 180, and just leave the pi off. You can convert that to a fraction. So that's going to be 5 out of 6. So that would be 5 pi over 6. 5 pi over 6 is the same thing as 150 times pi over 180. So that's going to be 5 pi over 6. And then question 3, what is the value of sine of pi over 3? What you can do on this problem is we can actually bypass the unit circle. Click on the graph settings, make sure you are in degrees. Take your pi over 3, multiply by 180 over pi, and convert that to a degree. So pi over 3 multiplied by 180 over pi is 60 degrees. Then you can type in sine 60. That gives you 0.866. That's not going to be 1. That's not 1/2. If you're iffy on which one of those two fractions gives you 0.866, put them into Desmos. Square root of 3 divided by 2 and square root of 2 divided by 2. Square root of 3 divided by 2 is 0.866. Square root of 2 divided by 2 is 0.707. So your answer is going to be A. Part 3. Which is the amplitude of the following function? So we just came off of this unit. So the amplitude is the leading number, no negatives, can't be negative. So amplitude is always a positive number. That's your A value. What is the period of the sinusoidal function with the equation y equals 3 cosine 1/2 x? The period is 2 pi over b. So your b value is 1/2. So 2 pi over 1/2. You can divide a fraction by multiplying by its reciprocal. So you can say 2 pi times 2 over 1, and that period will be 4 pi. Let me also show you on a graph how you can identify the period of a cosine function. In this case, make sure you are in radians. So graph it, settings, radians. you would put in the function 3 cos parentheses 1 over 2x, and you can see your cosine function. In fact, you can see your maximum, you can see your midline is 0, and you can see that amplitude is 3. And if you go all the way over to here, that next peak, you can see that it starts over again at 4 pi. That's your period. So indeed, 2 pi divided by 1/2 is going to give you 4 pi. And we can do that with this one too. We can find our maximum value by graphing the function. So we can say y equals 5 sine x minus 2. And our maximum value is 3. We can get that by taking your midline and adding your amplitude. So that's going to be -2 plus 5, which is 3. So you can get your maximum value from a graph, or you can do midline plus amplitude. Part 4. Graph transformations, left, right, down, and up. We are going to kind of do some of the basics here. So if we're trying to shift it down 2 and right 3, remember right or left is the opposite in a function with x. So if I'm going right 3, I actually want to say x minus 3 and see that third power, so it's going to be to the third. If I'm going down 2, it's going to be minus 2 at the bottom. So right 3, down 2. If you're ever in doubt, graph the original function, x to the third power, and graph its new function, x minus 3 to the third. As you can see, it's shifted right 3, and then you can do minus 2 at the end, and it's down 2. So minus 3, minus 2. Number 2, describe the transformation of the graph 2x squared minus 3 compared to x squared. Well, let's start by, does it go right or left? No, because it doesn't have parentheses. But it does go down 3. And this 2 is going to make it be stretched out vertically. So it's going to have a vertical stretch, and it's going to go down 3. So you can compare x squared, and then you can do 2x squared. There's your vertical stretch. You see how it doesn't shift it. But then if you do minus 3, it does go down. So vertically stretched and down. Question 3. F of x equals the absolute value of x. Reflected, stretched by a factor of 3, translated down 5, and left 4 to form g of x. What will the new transformed function be? Let's graph the absolute value of x. You can do shift in the vertical bar above enter. There's your absolute value. If I want it to be reflected, I'm going to have a negative out front. So that's going to be a negative. If I want it to be stretched by a factor of 3, it's going to have a -3 out front. So we'll put that 3 there, and that'll stretch it out. If I want it to go down 5, I'm going to put -5 at the end. That shifts it down. And if I want it to go left 4, I'm going to put +4 inside. So you can see the new function, -3 plus 4 minus 5. Number 4, the graph of the function f of x equals square root of x will be shifted left 4 and up 23. Left and right is the opposite, so left 4 will be +4 again. Square root of x, sqrt x, sqrt x plus 4, shifted it left 4. And up 23, that's going to be +23, way up there. So +23 at the end. +4, +23, okay. Number 5, Which of the following functions shows the parent graph? Absolute value of x translated up 4 and right 6. Up 4 would be plus 4. Right 6 would be minus 6 in the absolute value. We can verify that. X minus 6 is right 6, and then plus 4 is up 4. And then finally, describe the transformation of x squared plus y squared equals 16 to x minus 3 squared plus y plus 4 squared equals 16. This is a circle equation centered at the origin. This equation moves to 3, negative 4. Remember the opposites of both of those for the center. So it's going to go right 3 and down 4. You can verify that in a graph. X squared plus y squared equals 16. Remember that radius is 4. And then x minus 3 squared plus y plus 4 squared equals 16. And so you can see it went right and down. So right 3 and down 4. We can zoom in on that center if you want. That center should be 3, negative 4. So right 3, down 4. All right, that concludes review number 2.